So today let us solve the exercise problems. Exercise 2.2. Here the first question is you need to prove the followings. Okay, under that first question is 3 sine inverse x is equal to sine inverse of 3x minus 4x cube, and x belongs to the closed interval minus 1 by 2 to plus 1 by 2. Okay, fine. Let us begin with the solution now. Okay, since we need to prove, right? So consider sine inverse x as y. So then you can write x as sine y, right? Fine. Now you consider RHS part of the question. What is the RHS part of the question? That is sine inverse of 3x minus 4x cube, right? Now we know what is x. Just do replace over here. That is sine inverse of 3 sine y minus 4 sine y whole cube. Still you sort it out. This is 3 sine y minus 4 sine cube y. And now if you observe this, you are familiar to this. Why it is so? Just do recall the formula of sine 3 theta. What is the formula of sine 3 theta? That is 3 sine theta minus 4 sine cube theta, right? Therefore, you can write 3 sine y minus 4 sine cube y as sine 3y, right? Now you know that sine inverse and sine are inverse to one another. Therefore, it cancel it out. Therefore, what will be the remaining? That is 3y. So, what is, if you observe y, what is y over here? Y is nothing but sine inverse x, right? So, just do replace. That is 3 sine inverse x. And if you observe the question, this is LHS part of it, right? So you have considered RHS part, then you have proved LHS. Let us solve the second problem. So here 3 cos inverse x is equal to cos inverse of 4x cube minus 3x, and x belongs to 1 by 2 comma 1. Okay. So here let us consider cos inverse x as y. Therefore you can write x as cos y, right? So this is as similar to the previous problem. Okay, just consider the RHS part of the question. So this is cos inverse of 4x cube minus 3x, right? We got what is x. So just do replace. That is cos inverse of 4 cos y whole cube minus 3 cos y, and this will be cos inverse of 4 cos cube y minus 3 cos y. And now this is also familiar to you. What is the formula of cos 3 theta? Cos 3 theta is 4 cos cube theta minus 3 cos theta. Therefore 4 cos cube y minus 3 cos y can be written as cos 3y. Therefore, cos inverse of cos 3y will be 3y, right? Now, what is y? Y is nothing but cos inverse x. Therefore, you just do replace, and this is your LHS. Let us now solve problem number 3. Tan inverse 2 by 11 plus tan inverse 7 by 24 is equal to tan inverse 1 by 2. We have already learned few properties, right? In that property, you might have observed, that is tan inverse x plus tan inverse y is equal to tan inverse of x plus y divided by 1 minus xy. Right? So the same property can be used to solve this problem. So consider the LHS part of this question. So here tan inverse 1 by 2 by 11 plus tan inverse 7 by 24 can be written as, so here this refers to x and this refers to y. Okay, so this can be written as tan inverse of, so x is nothing but 2 by 11, 2 by 11 plus y is nothing but 7 by 24 whole divided by 1 minus 2 by 11 into 7 by 24. Fine. Now just go on solving this. That is tan inverse of, just take the LCM of this. So the numerator will be, just take the LCM over there, so that this will be 48, so plus 77 divided by 264. Okay, so I'm talking about the numerator. Just cross multiply. Okay, so that you'll get this in the numerator divided by, so here 1 minus 7 2s are 14 divided by 11 into 24 is 264. And in the next step this will be cross multiplied. So tan inverse of 48 plus 77 is 125 divided by 264 whole divided by, so cross multiplying this, 264 minus 14 divided by 264. So this would be tan inverse of 125 divided by 264 into 264 divided by, and this will be 264 minus 14 is nothing but 250, and this get cancels, and the remaining will be tan inverse of 125 divided by 250. 125 ones are 125 twos are. So this is tan inverse of 1 by 2, which is your RHS. Okay, so this is how you prove problem number 3. Let us now solve problem number 4. So here first we calculate 2 tan inverse 1 by 2. So using a property that which we have already studied in this lesson. So if you observe 2 tan inverse 1 by 2, this looks as similar to 2 tan inverse x, right? So what is 2 tan inverse x? 2 tan inverse x is tan inverse of 2x by 1 minus x square, right? So here replace x by 1 by 2. So you'll get 2 tan inverse 1 by 2. See, I'm replacing over here. Okay, 1 by 2 is equal to tan inverse of 2 into, instead of x, 1 by 2 divided by 1 minus 1 by 2 whole square, right? So this would be tan inverse of this 2 get cancels, therefore in the numerator only 1 divided by 1 minus 1 by 4. Just do a cross multiplication over here. So this will be tan inverse of 1 by 4 minus 1 divided by 4. And this will be tan inverse of 1 by 3 by 4. Okay. And this will be tan inverse of, you can write it as 4 by 3. So you got what is 2 tan inverse 1 by 2. Okay. Now if you observe the question, here there is one more part that is attached to 2 tan inverse 1 by 2. So let us solve that together. So consider the LHS part now, that is 2 tan inverse 1 by 2 plus tan inverse 1 by 7. So we know what is 2 tan inverse 1 by 2, right? So just do replace. That is tan inverse 4 by 3 plus tan inverse 1 by 7. Now, we're using a property that we have studied. That is tan inverse x plus tan inverse y is equal to tan inverse of x plus y divided by 1 minus xy. So this is the formula. Using this, we'll solve this. So here what we do is, instead of just replace x by 4 by 3 and y by 1 by 7. Okay, so here tan inverse 4 by 3 plus tan inverse 1 by 7 is equal to tan inverse, so in the x place 4 by 3, in the y place 1 by 7. Therefore in the RHS it will be 4 by 3 plus 1 by 7 divided by 1 minus 4 by 3 into 1 by 7. So this will be tan inverse of, so here 4 by 3 you need to sort it out using a LCM or cross multiplication. So whichever is easy to you can go through that. Okay, so here 28 plus 3 divided by 21. So this will be in the numerator. I just took a LCM of this. This is into 7 into 7 into 3 over here. Okay, so this is in the numerator, and if you solve the denominator, this would be 21 minus 4 divided by 3 7s are 21, right? Anyhow 21 and 21 get cancelled. So therefore tan inverse of 28 plus 3 is 31 and 21 minus 4 is 17, which is your RHS. See, right? So this is how you prove problem number 4 of exercise 2.2. Let us now solve problem number 5. So here what you have to do is, you need to write the simplest form of this problem. So here first thing is to notice is, we want this term, or we need to convert this term in the form of tan function. Why it is so? It is only because tan inverse and tan are inverse to each other. They will cancel it out and you'll be remaining with the answer. So if it is instead tan inverse, if it is sine inverse or cos inverse or other things. So okay, for example, if you consider sine inverse, then I want this terms in terms of sine function. Since it is tan inverse over here, so I'll convert this terms in the form of tan. So let us see how we can convert it. So here, before solving this part, what we have to do is, we need to put some value for x. So what will be the value of x? So whatever the value you choose for x, that should help to remove the square root of this. According to the problem, you need to put x values. Okay, so here I'll put x as tan theta. Why it is so? It is only because to cancel out the square root. Okay, fine. Let us see how it is so. So tan inverse root 1 plus, so instead x we have considered tan theta, right? So this will be tan theta whole square minus 1 divided by tan theta. Then tan inverse root 1 plus tan square theta minus 1 divided by tan theta. Now if you observe this part, 1 plus tan square theta, it looks familiar to you. That is nothing but, if you recall the formula of secant square theta, what it is, that is nothing but 1 plus tan square theta, right? So just do replace. That is secant square theta minus 1 divided by tan theta. Now, as I said, this square and this square root will get cancelled, right? Therefore, the remaining is tan inverse secant theta minus 1 divided by tan theta. So, still there is lot to solve. Why it is so? We did not got this term in the form of tan, right? So, let us see how we can solve further. So, secant theta is nothing but 1 by cos theta, right? So, cos theta minus 1 divided by tan theta is nothing but sin theta by cos theta. Fine. Now, tan inverse. So, this is cross multiplied over here. Therefore, you will get 1 minus cos theta divided by cos theta. And if you look at the terms of, look at the denominator, this will be into cos theta by sin theta. So, this and this get cancels and the remaining will be tan inverse 1 minus cos theta divided by sin theta. Right? Now, still we did not got tan function over here. Right? It is, so what to do with it now? So here we know what is cos 2 theta, right? Cos 2 theta can be written as, or the formula of cos 2 theta is 1 minus 2 sine square theta. See, while solving these kind of problems, you need to recall all the formulas that you have studied in the previous year. Okay, fine. Now, what I'll do is, I'll replace theta by 2. So that this will be cos 2 theta by 2. So I'm replacing theta by 2. Okay. Is equal to 1 minus 2 sine square theta by 2. So here 2 and 2 get cancelled. Therefore, cos theta is equal to 1 minus 2 sine square theta by 2. Now, if you shift the terms, you'll get 1 minus cos theta is equal to 2 sine square theta by 2. So, consider it as equation number 1. Now, what is sine 2 theta? This is the easiest formula that is to remember. That is 2 sine theta into cos theta. So here also I'll replace theta by 2. Therefore you will get sine 2 theta by 2 is equal to 2 sine theta by 2 into cos theta by 2. Now this will be, this 2 and 2 get cancelled. Therefore sine theta is equal to 2 sine theta by 2 into cos theta by 2. Consider it as equation number 2. So now, using equation number 1 and 2, we can solve this. So just do replace. That is tan inverse. So in the numerator using equation number 1, in the denominator using equation number 2, that is 2 sine square theta by 2 divided by 2 sine theta by 2 into cos theta by 2. Fine. Now, this 2 and this 2 get cancelled. And here, sine theta by 2 and 1 sine theta by 2. Okay, here sine square theta by 2, right? So, sine theta by 2 into sine theta by 2. So, 1 sine theta by 2 will get cancelled out. Therefore, in the numerator, sine theta by 2 will be remaining over here. And here, denominator, cos theta by 2. And you know that sine theta by cos theta is tan theta. Therefore, sine theta by 2 divided by cos theta by 2 is tan theta by 2, right? Yes, just to replace. That is tan inverse of tan theta by 2. We are at the end of the problem. So as I said, we have converted the term in the form of tan function. Fine. Therefore, now what you can do is tan inverse, tan are inverse to each other. Therefore, they will cancel out, right? Therefore, what will be the remaining? Remaining is theta by 2. Fine. So this implies theta by 2. Now, we know x we have taken as tan theta, right? Therefore, theta can be written as tan inverse x, right? So just do replace. So this is tan inverse x by 2. Or else you can also write 1 by 2 tan inverse x. Okay. So this is the simplest form of tan inverse root 1 plus x square minus 1 divided by x.